Hello everybody, this is Raman Chaube and we are about to begin the Euclid Element first book and common notion. Here will discuss about the main concept of Euclid Element and its theorems. First, we are going to start with the common notion. Euclid has given the common notion in his Euclid Element, Book 1. The common notion, sometimes called as an axiom, and it refers the magnitude of one kind only. In Euclid element, there are different kind of magnitudes include like, line, angle, plane figure, and solid figures. Now we will see the common notion 1. The common notion 1 is things which are equal to the same thing also equals to one another. As we have studied earlier, that Euclid is going to consider the same magnitude quantity, like if he is going to compare line, so he can compare line with the line, or plane figure with the plane figure, or solid shape with the solid shape. Here we can compare the same thing. So here what is the common notion? Things which are equal to the same thing also equals to one another. This we can understand with one example, that suppose we have a rectangle which is equal to the circle. In what respect? Rectangle area is equals to the circle area, and area of circle is equals to area of triangle. So as per common notion 1, the area of rectangle will be equals to area of triangle. This is the common notion 1. Algebraically, we may consider in this form also. We may write, suppose A is one quantity which is equals to B, and B is equals to another quantity C, which implies that A will be equals to C. Sometimes this is called transitivity of two numbers. But here in our Euclid element, we will consider the things in the form of angles. If we are going to consider the angle, if two angles are equal, first angle is equals to second angle, and second angle is equals to third angle, then first angle will be equals to third angle as per the common notion 1. Here is common notion 2. The common notion 2 says if equals are added to equals, then the whole are equal. This simply we can understand in mathematical phenomena using algebra. Using algebra, we can consider the two quantity x and y which are equals to each other. And as per common notion 2, we can add equals to both the equals, means here we can add the quantity z from both the equal, and the whole which we will get is equals to one another. Now this we may also write as z plus x or z plus y. Here we must notice that if these two are equals to one another, we can add any quantity in both the side. So the third common notion. The third common notion says if equals are subtracted from equals, then remainder are equal. So if we have the two equal quantity, let me consider as a x is equals to y and z is another quantity, then I can subtract z from x and y, and the remainder after subtracting z from x and y from z from y, both will be equals to one another. The same common notion can be expressed as if w is another quantity, then I can subtract w minus x and y from w, and the remainder will both time equal. So these two are also, and these two are also the different part of the common notion we may consider is the first part, and this is as the second part. Here is common notion 4. The common notion 4 says things which are coincide with one another equals to one another. This common notion requires little bit elaboration with example and also interpret with the different form like interpretation through geometry, interpretation through algebra. Here we can interpret it, or we can explain it in a different simple form. We can say if two things are identical, they are equal. Also, geometrically, we can say if two objects are superposing or superposed each other, then they are called as a equal. So we are taking two rectangle. These two rectangle will be called as equal if they will superpose each other. If we are superposing each other, they will completely cover each other. And this is the beginning of congruency, because congruency, when we are going to start, this is the first proof which we are going to come across, that uh, prove that the two triangles are congruent. On that time we are using, or Euclid has used, as a congruency. Okay, so this is a geometrical interpretation. Now we can move for algebraic interpretation also. How we can use algebraic interpretation? The two things are equal if they are same or they are identical. In algebra, the things which are equal are always equal. This phenomena we have already seen. So this common notion for, we can say that every number, suppose x is one number or x is one quantity, then x is always equals to x. Means if we are thinking for a triangle, then the area of triangle is always equals to area of this same triangle. In algebra, this property is called reflexive property. So this is reflexive property. And what is reflexive property? The things which are equal to the same thing. Means if we are taking a triangle, the triangle will be, the area of the triangle is going to be area of same triangle. On the same way, one number is always going to be equal to the same number. So this is the last but not the least, common notion 5. Common notion 5 says the whole is greater than the part. And what generally it means, we can consider the whole is greater than parts, and it can be interpreted as definition of greater than. And this was the basic definition we can say that the mathematics can consider. Here we can consider if B is the part of another A, then any quantity A, then A, the quantity A is sum of B and C. Here C is another magnitude or the quantity. In geometrically, if we are considering B is the part of, B is a rectangle, or one rectangle is equals to a square and a rectangle, a small rectangle, then the particular rectangle is greater than the square also and a small rectangle also. On the same way, we symbolically are writing A is greater than B, means there is something C which when we will add it, we will get as a A. This is very important concept. A is equals to B plus C if A is the whole and B is the part. Now, this was all about the common notion which was given in Euclid Element, Book 1. Thank you very much for watching this video. Happy learning. Thanks. Thank you very much.